Well, good morning, good afternoon, or good evening, wherever you may be in the world. And we'd like to welcome you to RTDology, Burns Engineering's online training series. I'm Jeff Wiggin, National Sales Manager at Burns Engineering, and presenting today will be Bill Berquist, our Principal Applications Engineer. Today's presentation is Wireless Temperature Measurement Right for You, is the latest of our web-based training modules designed to help you better understand temperature measurement and achieve your measurement goals. If you've joined us for any of our previous sessions, we'd like to welcome you back. If this is your first time, welcome. And when you get a chance, do go ahead and check out our previous presentations on our YouTube page. You just need to search for RTDology. Before we get started, just a few housekeeping items. To respect everyone's time, we'll make every effort to limit the presentation and Q&A period to about 45 minutes. We do highly encourage questions, so please type them into the Q&A section or the chat box on your screen and send them to host and presenter. We'll attempt to answer as many as time allows. Today's session is being recorded and we will post it on our YouTube channel. So if you miss something, don't worry, it will be there posted for you shortly. If we don't get to your questions or you do need some additional assistance, there will be contact information provided at the end of the presentation. And finally, our goal is to answer your temperature measurement questions and challenges. We've built our RTDology series around commonly asked questions and issues. However, if you have a topic you'd like to have us consider, give us a call and we'll see what we can put together for you. So that kind of covers the housekeeping, but before we get started, we'd like to conduct a quick poll to see where everyone stands on the status of wireless technology and temperature measurement. So we'll have a quick poll started for you here, and if you could just answer the questions, we'll show the results in a minute here. All right, so it looks like we've got most of the responses done. So if we can post the poll results, it looks like we've got about 39% of the folks have some understanding of wireless technology, and everybody else kind of falls somewhere in between, which is good. So that's exactly what we're looking for in this session, to give you a little bit of background and maybe make you a little bit dangerous, but at least let you know what questions you need to ask as you're considering moving to wireless temperature measurement. So with that, I'd like to hand it over to Bill Berquist for him to share some knowledge and help you in determining if wireless temperature measurement is right for you. Bill, take it away.
Well, hello everybody. We are all broadcasting from remote locations today, so if you hear some dogs barking or kids screaming or whatever, that's probably why. So we can move on here. What we're going to try and help you with today is to answer that question, is a wireless temperature measurement going to fit into your process system? We're going to look at some of just a quick overview of what it is, look at some of the features, benefits of it, and then some of the more important parts of it are the installation considerations, especially antenna location. We'll spend quite a bit of time on that. So with that, I want to just first look at a typical wireless installation, just so you get some idea of what kind of a typical industrial style setup might be. This diagram shows groupings of wireless transmitters in 4 different locations. And these transmitters and temperature probes here, it's just a standard RTD or thermocouple probe connected to a wireless transmitter. And they will transmit wirelessly to a gateway. And now this gateway is kind of just a traffic cop for all of the sensors that are reporting to it. And in this case, these are reporting to a central gateway, which then sends that information to a control system, whether it's a PLC or a DCS system, whatever it might be. So this is just kind of a typical setup, and I think this particular manufacturer claims, I think it was 63 temperature points per gateway. Seems like quite a few. With these, the temperature probes are just standard off-the-shelf probes. The transmitter is what's doing all of the converting that to a packets that it sends to the gateways. And then some of the terminology that gets thrown around, one of the simplest types of a wireless system is what they call point-to-point. And this might be if you just want to send a 4 to 20 milliamp signal from one location wirelessly to another. There's typically no software setup or anything. It's just install these two things, hook them up to the temperature probe and transmitters, and it'll send that 4 to 20 milliamp signal between the two. And you can expand that with a modular wireless I/O system, input-output system, and it just adds additional points at both of those locations. Then the gateway I mentioned a little bit, it's just kind of a little traffic cop for the individual sensors to send their information to, and it keeps everything organized. And then the last couple of things here are the antenna types. There's the directional style, and then the omnidirectional, which just sends the energy all in multiple directions, in all directions. Whereas the other one it's used mostly for really long distance transmission. So the costs of these systems, this manufacturer makes some pretty good claims here as far as how the cost compares to a wired system. You know, they're claiming the devices are quite a bit less costly, and the installation time, pretty significant savings there, 65%. And then all of the you know, instrumentation cabinets, rack things, it's just, there's a lot less of that required because of the elimination of all the wiring that goes along with a traditional system. And we look at further reducing costs. An example here that I had discussed with a customer a while back was with some mobile mixing vessels. So they had several of these vessels in a room, and each one of them had temperature and some other instrumentation attached to it. In addition, they had some, I think they had some power attached to it because some of these had a mixer in them, for example. And some of the benefits of going wireless on a system like this would be that when people go to move these tanks around to, you know, go fill them and then bring them back, they would forget to unplug all the different cables and things, and they'd end up breaking things. So going to a wireless system there would eliminate those kinds of errors. You know, cuts down a lot of the maintenance cost that way. Plus, when you have electrical connectors and especially RTD probes and thermocouples, when they start to wear out, it can cause a measurement error. You get a little bit of extra contact resistance in one of the pins on an RTD, and that can throw off the lead compensation. But by going wireless, it eliminates a lot of those types of problems. And one of the biggest challenges with this application, and the one that actually really killed it from implementation, was location of the antenna. Wireless systems have onboard antennas and some have remote antennas, and there just wasn't a good way that we could mount the antennas on these particular vessels so that it would accomplish what the customer wanted to do. They typically have to be mounted line of sight, and we'll talk about that a little bit later here. And then it would have required some modifications to these vessels, which at the time he wasn't willing to do. But anyway, so that's kind of a typical application where it would help you reduce costs and potentially improve your efficiency of the operation, just because you don't have all these wires to disconnect and deal with. And when it comes to installation of these, one of the biggest benefits is that it goes a lot faster. We don't have to be digging holes or cutting concrete to run trenching and conduit. And all the engineering that goes along with that. It's pretty much you set the temperature transmitter and probe out where you want it, go back and program the gateway and turn the system on, and away you go. Some of the other things that help out here with going wireless, a lot of the data that comes off of this is easily accessed. And if you have hazardous areas where people may have to go in and look at a dial temperature gauge, for example, if it's like on a bimetal thermometer somewhere, replacing that with wireless can send that signal over remotely somewhere, eliminating that hazard of someone having to go out there and check it out. Security is one of the big issues with wireless that I've heard about. There are most of these systems that I've looked at use this advanced encryption, so it's an AES. You've probably seen that acronym, and it's 128-bit, so it's fairly secure. And reliability is another nice feature of these. And I've looked at a couple of these with the software, and what they do is it's kind of reporting, in the case of a battery-powered remote transmitter, wireless remote transmitter, it'll send back information on its battery voltage, the data that it's sending. It'll keep track of that and tell you if there's any issues with it. Certainly, if the probe goes bad, it'll alert you of that right away. So there's some of the ways that the manufacturers of the newer wireless systems have addressed security and reliability. Environmental compliance, a good example of this happened recently right close to Minneapolis here. There was a company that had a remote storage lot for used tires. So they had just mountains of these old tires, and they ended up having a fire. Something caused it to start on fire. And I couldn't help but thinking at the time that this would have been a really good application for a wireless temperature monitoring system. They could have just buried a few sensors, close by or even in this pile of tires, and have it send that signal wirelessly back to their office, which was quite a ways away from where this storage place was. Certainly would have eliminated a lot of the pollution that happened with that, because it burned for quite some time, and there was a lot of air pollution, a lot of ground pollution just from the stuff that oozes out of tires when they burn. So what I thought would have been a good application for a wireless temperature monitoring system. One of the other concerns with wireless is that, well, can I add it to my existing wired system? What is the output like? How does it work? And most of these systems I've looked at will talk directly to whatever control system, or if you have a cloud-based system, there's an output that it'll talk to. Seen this particular one has a Ethernet connection to it, along with pretty much any other kind of output that you might need. It can be configured to do that. One of the other benefits of wireless, if you have varying temperatures in remote locations or places that are hard to get to or hard to run wires from, it can work really well for that. one of the applications I had several years ago would have been a really excellent application for wireless. It was a cooling pond for an electrical generating plant, and the local Department of Natural Resources there required them to monitor the temperature in the cooling pond as well as the discharge water from it into a river, and then it was downstream like a mile or so. There just happened to be a bridge there that we thought would be a good location to mount the temperature probes, and they were run up to some transmitters that were mounted on the bridge, and they had to wire in power from nearby power lines. And then the decision was, well, do we just put a local chart recorder there and have somebody go out and look at it every once in a while so that we can show that we're meeting all of these regulations? Or do we trench a wire all the way back to the control room, which was several hundred yards away? It would have been hugely expensive to do. And that particular one with wireless, it would have been very simple to mount a battery-powered wireless transmitter on that bridge, hook up the temperature probe to it, and have it broadcast back to a gateway back at the control room. Would have been very simple to do, very inexpensive, and it would have been very fast to accomplish that. And with that, I think we're going to do another poll, right, Jeff?
Yeah, exactly. So it looks like there's quite a few benefits to going wireless. And before we get into some of the installation questions and concerns, we'll another quick poll, really just to find out kind of how soon you plan to implement wireless temperature measurement, or if you're planning on doing it. So we'll take a minute or so here and try to get some answers to that question, so we can kind of get a feel for what people are thinking about in terms of moving to wireless. And then we'll move on to the installation. Did also want to note that if you do have a question anytime during the presentation, do go ahead and type it into the Q&A section or the chat section, and we'll be sure to get to that question at the end of the presentation. There have been quite a few questions about battery life and what can we expect and those types of things, and I'll assure you that Bill will hit on that towards the end of the presentation here, so we'll get that one captured for sure. So I think if we want to close out that poll now, it's looking like about 20% of people have a plan, but no timeline for it, and there's probably another 16% that don't have a plan right now for wireless. So it's good to know. We appreciate the feedback. So with that, Bill, if you'd like to move on with installation, we'd love to hear it.
All right. Well, so I mentioned earlier that the antenna location is important, and so far I've seen this as kind of one of the more difficult things that we need to deal with when we're looking at, can we use wireless temperature measurement for a particular application? And I think a lot of the effort comes into antenna location. We need to have line of sight between the temperature transmitter and that gateway. And then there's some issues with interference, and we'll talk about those in a little bit here. One of the biggest ones is precipitation. Again, heavy rainfall, it can be a problem. And sometimes the remote antenna, you can mount those in a little different locations, higher up or wherever, and take care of some of those issues. And then there's always a big question of, well, how far can I send this signal? And it really depends on a lot of these factors with how it can be located. Are there trees in the way, buildings, mobile, whatever, this and that. But kind of the maximum is about 40 miles, and that's with the directional style antenna, remote antennas at each end. I've seen other systems that use, they claim about 130 feet up to maybe 400 feet roughly. You know, and a lot of that has to do with the power that the transmitter is putting out. You know, of course, the farther you're going to send that signal, the more power it's going to take. And location of these, and of course, you got to use real high quality cables. If you use low quality cable, you can lose some of that signal between the antenna and the transmitter. And this particular manufacturer, they had claimed they'd like to have 10 feet of ground clearance and then some separation between the different antennas. So there's a lot of consideration, not only with the type of antenna, but where it's going, how it's mounted. Then we just have to make sure that we have this clear line of sight. And I mentioned increasing the distance. This requires a fourfold increase in the power to send that signal. If we look at a little graphic here, if you got a big obstruction in place, things aren't going to work right. The ideal situation is to have this straight line of sight between the two transmitter gateway. For those of you that are somewhat familiar with wireless transmission, there are different frequencies that these things operate over. For example, the 2.4 gigahertz, that would be similar to what your wireless router at your house is broadcasting on. There's also, I think, some of the dual band wireless routers do, I think it's a 5 gigahertz or 5 point something. One of the better frequencies for wireless is the 900 megahertz. Seems like that's got a little better range, and you do need to use a bigger antenna to do that, but it's fairly reliable, not a lot of interference issues with it. Well, the 2.4 gigahertz items do have some kind of a shorter range. Sometimes there's enough of those 2.4 gigahertz wireless gadgets around that you can get some interference. And that can come from other radios and solar. And I think it would seem like with solar, if we were having some interference with your wireless measurement system, we'd be having interference with a whole bunch of other things, and that might be one of our least concerns. I mentioned precipitation. That, again, can be a big problem. Trees and buildings, you know, it can, the 900 megahertz band, even 2.4, can go through some, you know, a few trees. But if you have a forest between transmitter and gateway, it's not going to work right. You also have to consider mobile things. So if you have a case where you're trying to broadcast things across the parking lot, probably need to make sure that the antennas are up high enough so that if someone pulls a semi in and parks it for a few hours, it's not going to be blocking your signal. I briefly mentioned software a little bit earlier. Some of these systems that have multiple gateways and things require software to set up and configure not only the gateway but also the transmitter. And so you do need to have some kind of a comfort level in learning that particular software system, how to use it. And of course, it gets a little more complex with the more temperature points that you add. And if that kind of a system does not appeal to you, then there are systems that are the point-to-point, which I had mentioned earlier when we were looking at terminology, and there's no software with them. You set up this radio, put some power to it, hook it up to your RTD or thermocouple probe that's connected to a transmitter, and that reads that 4 to 20 milliamp signal from that transmitter, sends it wirelessly to a receiver back in your control room. Those types typically have a remote antenna that you can mount wherever it's convenient so that you get good line of sight between the two. So I guess the bottom line there is if you like to use software, there are systems that do it that way. If you don't, there are other options to do it without software. And finally, Jeff mentioned that there have been quite a few questions about power requirements, and all of these wireless transmitters can be powered with line power or battery powered. In the case of battery power, lifetime is going to be highly dependent on how often that the transmitter is taking a measurement from that temperature probe. And if you look at the chart here, it goes anywhere from 1.5 years to 10 years, depending on how you have that transmitter configured. There are also solar panels that are used frequently with these to help keep the battery charged and extend that lifetime. Of course, they're going to work really well outdoors. If you have them indoors, you are going to get some, as long as there are lights on, whatever, it's going to give you a little bit of energy boost there. And there may be some other systems that may take some parasitic power off of various things that you can use to help keep those batteries charged. So, and I guess with that, I think we have another poll coming up, Jeff, is that right?
Yeah, correct, Bill. So just a quick poll on what do you see as the biggest obstacle to implementing wireless technology for your company or the applications that you're thinking of. So we'll go ahead and get that poll out there, and if you want to do a quick vote on it, and we'll take a look at the results here shortly. And then just did want to share with people as well. It's as we were putting this presentation together, it's really struggling. We really struggled with, how much information to give, how much not to give, because wireless, unlike typical wired applications, every application is significantly different, and there are many, many different ways to configure wireless networks as well as transmitters and the sensors themselves in order to give you what you're looking for. So what we decided to do was just try to give you, let you know what some of the benefits were to going to wireless, and then also some of the considerations that you need to take into account, and the questions that you need to ask, questions you need to ask yourself as your company looks to do this, but also questions to ask your supplier. So, what about this? What about, line of sight? What do I have? Do I have power? Don't I have power? How long do I want the batteries to last? Do I need continuous monitoring or intermittent monitoring? Do I want to try to control with it, or is it simply just a monitoring device? So we really just wanted to give you those questions so that you're a little bit more informed about what you need in order to really look at moving to wireless. So looks like with our questions or with our quick poll, it looks like maybe the biggest concern is on security risks at about 18%. Others is kind of some cost, and then lack of understanding or technology kind of bring up the last two. So appreciate you giving us that feedback. And with that, Bill, why don't you finish up your presentation?
Yeah, I'm not surprised about the security risk finding. It's been kind of the biggest concern that a lot of people have had with all of these different types of systems. And as I mentioned earlier, most of these that I've looked at, like the wireless heart, and the other 900 megahertz version, Zigbee, ISA 100, they all talk about using this AES 128-bit encryption. So fairly secure. So, it doesn't mean, I suppose, that somebody couldn't screw it up somehow, but I think for the most part, it seems like they've got the security fairly well figured out. So certainly that's a big issue. Reliability is another one, and it's nice that a lot of these systems do have some self-reporting on the health of the network and the sensor that's connected to it. So some of the other things, I guess I look at these as just kind of the most important things to look at when selecting a system, or even trying to figure out if this is even going to work for your particular process measurement. Is just the location of the measurement. Can we get the antenna in the right place? Do we have clear line of sight? Is there anything that's going to interfere with it? And then finally, the power requirements. Certainly, if you have a system, you don't want to be going out there changing a battery every 30 days or something just to keep that measurement going. So there's some things to look at there. With that, I think we're just going to open this up to other questions. And Jeff, you'll have to feed those to me, and we'll see what we do from there.
Sure. So everybody, if you've got questions or need clarification on anything, by all means, type it into either the chat area or the Q&A, and we'll try to get you an answer. So one question, Bill, is can the battery charge level be sent to the PLC?
I believe so. The software that has the capability of identifying what that power level is, and I think it would be more, you'd have to look more at the capability of the PLC to know if it has that capability to accept that particular information from the gateway, from the actual gateway that you're using. It appeared that way from the one system that I looked at. It was a fairly robust system, had a lot of reporting information on the health of the network and the certainly battery power level.
Okay, and then a question again: is there any type of RTD or thermocouple, special RTD or thermocouple that needs to be used in a wireless system, or are you using standard sensors?
No, these are all standard sensors. The wireless part comes with the transmitter that it's connected to. So we could just take any catalog off the shelf, RTD or thermocouple, hook it up to the wireless transmitter, and away you go. There's really no difference with the probe itself.
Okay. A question here about how do you overcome the security obstacle for customers who are worried their instruments can be hacked? I guess I can answer that one. It really depends. It depends on what is the what level of security is the end user looking for, and at what every piece of equipment, wireless, can have different security protocols and how much you can put into one versus the other. So it's in the selection of the equipment. It's really understanding what their concerns are, and then it's selection of equipment. And then there's multiple ways where things can be passed through firewalls, that type of thing. There's very simple applications, as Bill talked about, kind of what we call AB radios. So it's just sending a signal from point A to point B, and it's giving you that the temperature is rising or it's falling. There's not a whole lot of information that can be given away with that. If you need something much more secure, you're also, the security is less maybe about the information that's being transferred wirelessly, and more about actually, because you've got a wireless signal coming in, can someone get into their internal network? And that's really something that you'd have to have conversations with people's IT departments and, what they're comfortable with and what's possible based upon the specific instrumentation or transmitters that they're looking at.
Yeah. So what, any other questions coming up here, Jeff?
Yep, I was just going to go back and look. How does adding humidity monitoring impact the battery usage?
That I really don't know. I would think that'd be a separate transmitter, probably very similar power requirements. There are it would seem like the power requirement's mostly going to be for doing the actual transmission of the signal. And I think that's where you use up the most power for sure, rather than just reading the sensor itself.
Okay. And then what is the expected lifetime of these sensors in an industrial setting, say inside a building?
Well, I think the transmitters and gateways and things are, probably looking at several years for sure. On the sensors, it's going to be whatever lifetime you're getting out of them now. That part doesn't really change. It's just the, how robust are the gateways and the transmitters and the other components that are in the system that you set up.
And really what we would look at if that was a concern to anyone, I mean, it's a piece of electronics just like any other electronics. So it's, in a fairly benign conditions, they can, last a decade. In more, dusty conditions or anything outside, you may have, they may not last quite as long. So you run into the same kind of considerations for wired versus wireless. It's really, understanding what the environmental conditions are that has the biggest impact. And the sensors, as Bill said, is really just, it's same as the wired sensors that you use now, is what you could expect with those. So if anybody's got any other questions, go ahead and type them into the Q&A or the chat area, and we'll try to get you an answer. I'm just taking a quick look to see if there's anything else here.
Yep, and feel free to email info@burnsengineering.com if you have some other additional questions later.
Yep, that would be excellent. And so just again, a reminder: this session was really just designed to give you some of those, give you a top level, a high level overview, and then also to give you some of the questions that you need to ask or some of the things that you need to consider if you're thinking about going to wireless. Really the best approach, to any wireless is if you've got an application, is to call up your supplier, whether that's, your temperature supplier, whether that's Burns Engineering or someone else. Call them up, say, here's what I'm thinking about. This is what the application looks like, and here's what I need to get out of it. And that's really the best way to determine if wireless is going to work in your specific application. Last question, or I guess that I will put out there because there have been a few people that have noted it. We make this RTDology session, I guess, is usually what we call non-denominational. So we try to educate people about temperature measurement. We don't typically get specific into what Burns is providing in terms of our models and whatnot. However, several questions have come up. So I will acknowledge that Burns does work with Oleum Tech on wireless technology, and so a lot of the images that you saw were Oleum Tech, and so that's one of the products that we offer. But there's other products out there as well that work much in the same way. So. All right, wondering, I'll take one more look, see if we get any other questions. And if not, doesn't look like we've got any others. So I want to thank everybody for attending, and we hope to see you at our next RTDology session, which will be in September. And as a reminder, this session has been recorded and will be posted on our YouTube page. So if you go to YouTube, all you need to do is search RTDology and you'll be able to find it. But if you do have any questions, do go ahead and give us a call directly or shoot us an email. We'll be happy to get you an answer. And with that, have a great rest of your day.